Hey, how's it going, everybody? It's going great, right? Yeah, I'm super tired this morning, too, so we'll all get through it together. My name is Pete. I worked on React for a long time, and I'm going to talk to you about React and jQuery and composability and all that fun stuff because this is jQuerySF. I wanted to open by saying that I really love the web. I built like most of my career on building stuff on the web. So I was the team lead of the Instagram web team, working on kind of enterprise-facing stuff, analytics products, all that kind of stuff, as well as the consumer side of the web. I was also on Facebook's JavaScript infrastructure team, building the core abstractions that all developers who write JavaScript at Facebook use, including React and some other stuff. And I was also on the React core team for a long time while I was at Facebook, which is the JavaScript library that Facebook uses to build pretty much everything these days. I left Facebook in September, and I started a company called Smite. We're a trust and safety as a service company. We actually were tech crunched like 3 hours ago, so that's why I'm really tired. So it's a very exciting time for me. But the best part about the web is that it's everywhere. Like, I can just write a little bit of HTML, and almost everybody on the planet should be able to consume that information. Doesn't matter, whether they have direct internet access or whether they kind of download it in batch. Doesn't matter if they're on planet Earth or if they're on the International Space Station. It doesn't even matter if they can see or not, or hear. The web is this universal information medium, and it's really awesome, which is why I really hate to say that I hate the web. Anybody here built a web app before? It's a terrible API for building web apps, or for building applications. It's just like this really hostile environment, and one of the great things that jQuery did was it made this environment just like, it reduced the hostility just enough that we could actually build stuff with JavaScript that was actually real and usable by people. And that was great, but it's still not an API designed for building apps. Now, there's a lot of efforts kind of moving forward right now around the web component standards. But what these standards are doing is they're taking kind of parts of the browser internals and they're exposing them to kind of user space, to the developer. And this is great. This is awesome. We really want to be able to customize our select boxes and stuff like that. But it's not a great API for building applications because someone didn't sit down and say, hey, we want to come up with a great way to build apps. Let's call it Shadow DOM. No, it's like we have this underlying browser-specific thing that renders widgets inside of a web page. Let's kind of clean up that API and call it Shadow DOM. So, these technologies are great, but they're not designed for building apps. It's more of the same. Another reason why building apps on the web is kind of terrible is DOM manipulation is slow. It's still slow even in 2015 because it's kind of slow. It's got 10 years at least of standards behind it that slow it down. So if you just console.log all the properties on a DOM node, there's like hundreds of them. And they're legislated to be there. So it's very difficult, if not impossible, to speed up a lot of these operations. And even at that point, it's hard to stay on the fast path because also the browser layout is slow. So if you read the wrong properties off of a DOM node or you read them at the wrong time, you might have non-trivial performance implications of that. So if you ever read .offset height off a DOM node, forces a synchronous style recalculation. Super slow. Also a source of browser inconsistencies between Firefox and the WebKit family of browsers. Kind of interesting. Another thing that's slow about the web is the standards process. These bodies take a long time to come up with the standards, and then they take even longer to roll out into browsers. ES6 was just standardized, a couple weeks ago? And that's been in the works for a long time. This is actually by design, and I think it's a good thing. Standards bodies moving slowly means that we get this kind of universal medium that everybody can access, and these standards get pushed out to everybody. It's an important part of the web, so I don't think that this is actually necessarily a bad thing. It just doesn't help us when we want to build applications. At the end of the day, this all boils down to one thing, which is the web is designed for documents, not applications. Has anybody else felt this way before? Okay, a couple people. Cool. So Facebook builds applications, and a lot of them run in the browser. These are applications where millions of people use them. They're interacting in real time across a wide variety of browsers. And Facebook does compete on user experience. If the Facebook messaging experience, for example, isn't great, then those users will go to another social app because it's actually fairly easy to switch in a lot of these situations. So when you're competing on user experience, you need to have a bunch of great performance, and you need the freedom to be able to build your interface exactly to the designer's spec. So Facebook needed a solution for building applications in the browser, not shoehorning documents into an application kind of UI. Sorry? So I like to pull out this Dijkstra quote a lot because it describes React exactly. We like to shorten the conceptual gap between the static program and the dynamic process. What this basically means is we want to make processes that execute over time look like they're executing at a single point in time, because our brains are really good at keeping a couple of pieces of information in them, and as you have a process evolving over time, you have to keep the entire history of everything that's happened in your brain to figure out what the hell's going on. So I'm going to give you an example. This is the Facebook chat buddy list, in the lower right-hand corner of your screen. As people kind of come online and come offline, this changes. You can click on them and message them. So I'm going to read off a series of events, and then I'm going to ask you to imagine what the list looks like at the end of these events. Sound good? Okay. All right, look at this, because this is the initial state. This is the initial state right here. Alice went offline, Bob went offline, Steve went online, Bob went online, Charles is idle, and Charles is on mobile. So what does the buddy list look like? Can anybody draw this? Can anybody remember who's online and who's offline? If you were just looking at a data structure like this, which is a snapshot of this user interface at a given point in time, it's very easy for you to describe what that user interface would look like. And so this is what React is all about. Before I kind of dive into the specifics of React, I just want to kind of talk about it at a high level. We launched React open source in 2013 at JSConf. We had been working on it for over a year before that and had it in production for a while. And everybody kind of laughed at it for the first 6 months or so. But today, it's actually Facebook's #1 GitHub project by number of stars. I don't know if number of stars is a metric worth talking about, but I'm going to talk about it anyway because I'm tired. React Native is #2, which is pretty cool since that was only released this year. React has had a pretty big impact over the past couple of years. It's actually changed the Angular and Ember roadmaps in addition to other frameworks as well. There's kind of two key examples that I have. The first is that Angular 2 is de-emphasizing two-way binding. React has been famous for kind of calling it one-way binding. So you have data, and it gets projected onto the DOM. The DOM doesn't project changes onto the data. You have to explicitly listen to events and mutate the state, rather than having the system automatically do that for you. The main reason for that is that when you have data flowing both directions, it gets kind of crazy to understand, where is the source of truth? How did this value come to its current state? If you think about all the times you've been debugging code, the easy pieces of code to debug, you can just step through the debugger and see kind of which branch was wrong. The hard bugs to debug are when you're looking at the current value of some variable and you're like, how did this possibly get set? And then you go down the rabbit hole. Another roadmap that React influenced was Ember, specifically around server rendering. So React was designed to kind of hedge against any environment that it's put in. So it should work basically on any platform that someone would want to build an app on. So this is, when it was first launched, this was the client-side browser DOM. A little bit after launch, it became server-side with Node.js. You can generate a static string of HTML, serve it up to Google, or serve it up to your Opera Mini clients or whatever, without booting up an expensive browser DOM. You can do that at scale. And we're starting to see other projects like Ember prioritizing this type of work. Within Facebook, there's also a new iOS-specific framework that they're working on called Components, which is very heavily influenced by the ideas of React. One-way data flow, immediate mode rendering. And we're starting to see a lot of traction in these compiled.js languages as well. React is now kind of the rendering system that a lot of these compiled.js languages are targeting. And if they're not targeting React in particular, so Elm, for example, targets virtual DOM, which is a kind of modular version of some of the ideas in React. It's still very heavily influenced by React. And now there's just tons and tons and tons of companies using it. So we call it a JavaScript library for building user interfaces. But just about every JavaScript library that runs in the browser calls themselves something like this. More specifically, we should call it a JavaScript library for building immediate mode user interfaces. What I mean by immediate mode is that it's a single snapshot in time, as if you just rebooted the app and re-rendered for that one snapshot in time. You just forget about the entire history of your app. I'll show you what I mean by that. This is a really simple clicker component. As the user clicks on the component, the number increments. Now, there's some crazy syntax in here called JSX. There's a holy war about it, but just think of those as function calls. It's a little bit easier to explain when you just can visualize the DOM structure like this. But what's important here is that in no part of this code do you look up where the count of the number of clicks is rendered. There's a render method that says, hey, given this number of clicks, here's the DOM nodes I want to render. So I want to render a div with an event handler, and I want to render this text. When we click on this, the event handler handleClick gets called. setState updates the internal state of this component, which is effectively the model. So it's a little JavaScript dictionary that contains the number of clicks. And then render gets called again, and it's as if you started from scratch, and you blew away the entire old component, and you re-rendered a new one. So this model is really simple because data changing over time is the root of all evil. If you want to test how this component looks in a particular state, you just start a new instance of it and give it that particular state. You don't have to work your way through the workflow of kind of moving your application into the state that you want to test. And if React doesn't have any bugs in it, the contract that React has with you is that, hey, that component will render the exact same given that state, no matter how you got into that state. So the core idea here is that you re-render the app on every update, just like you did in the 90s with a server-rendered web app. Now, say what you will about server-rendered web apps in the 90s, they were pretty easy to build in the sense that you didn't really have bugs with state transitions. When you wanted to update something, you ran an update query to the database, and then you downloaded a fresh web page. You didn't have different counts of things getting desynchronized because there were no more updates. But the real question is, can we make this fast? Blowing away the entire DOM on every update is going to be slow because the DOM is slow, like I mentioned earlier. So one of the cool things that React did was it abstracted away the DOM in something that we call a virtual DOM, which makes it possible for us to actually implement code in this style. So going back to this example, that div tag right there isn't an actual DOM node. It's a description of a DOM node. What this method says is, hey, React, I would like a div to appear with this event handler and with this text content. It doesn't talk to the browser API at all. You can run this on Node.js. You can run this on a JavaScript VM on an iOS device. Doesn't matter. It's all just regular, lightweight JavaScript objects. These have 3 keys on them. And what React does is React looks at that and makes the UI appear the way that this code wants it to appear. So whenever the UI is updated, so whenever setState is called as the result of an event, render is called again. And it re-renders a new virtual DOM tree. React diffs that virtual DOM tree with the previous one. It computes a set of DOM mutations to update that UI, and it tends to be a fairly efficient set of DOM mutations. It queues them, and then it flushes those mutations to the DOM at a time that's appropriate. That's generally at the end of an event handling tick. So if you do multiple transitions within a single tick, that will only end up touching the DOM once. And the way that React touches the DOM tends to be batched in the most efficient way possible. So this is similar to how game engines work. There's a great breakdown of how Doom 3 works. on this guy's blog. And basically the way that Doom 3 works is you have the state of the world, which is where are all the players, which doors are open, which power-ups are on the ground, where are all the NPCs. And then that game state gets fed into the game logic. So this is the rules of the game. How do you open doors? What, how do weapons work? Who can see what, et cetera. This is kind of like the high-level rules, not the physics engine and stuff like that. Then those rules of the game emit a scene intermediate representation. This is a high-level overview of what to draw. So, I want to draw a monster over there at this XYZ coordinate. I want my camera to be facing this direction, all that kind of stuff. And then the back end of the Doom 3 engine turns that representation into OpenGL operations that then repaint the screen and get sent to the graphics card. React is built in a pretty similar way. Rather than having the state of the game world, you have the application state. And rather than having rules of the game, the rules of the game are the React components. They implement your display logic. And then those React components return a virtual DOM representation. That virtual DOM representation gets diffed with the previous one to create imperative DOM operations that then get sent to the browser rather than the graphics card. And there's a lot of micro-benchmarking and performance wars going on in the JavaScript world. So I'm not going to make the argument that this is universally going to be the fastest way for every use case, but what we found is that this is the best set of performance trade-offs for most applications, for a number of reasons. Basically, when you have a performance-sensitive app, you tend to have a lot of data. And if your app is performance-sensitive, you can't render all of that into the DOM because it's going to be too many DOM nodes for the browser to handle. And the scroll bar is going to get too long. It's just going to be a bad user experience. So you tend to do something called windowing. So you show the first 10 items in the list, and then you click a button or you scroll down and it renders the next 10 items and so on. What Angular has done historically is it does something called dirty checking, which it walks through your model, and it figures out what's changed in your model, and then it renders to the DOM. And Ember does something somewhat similar, except it uses a concept called an observable. But the key thing is that they're tracking changes in the underlying data model. You can think of React as doing dirty checking on only what's actually rendered. So it re-renders that virtual DOM, and then it dirty checks the virtual DOM against the previous virtual DOM. And if you're rendering a reasonable number of DOM nodes, React's performance will always be reasonable. So yeah, you can probably beat it in some micro benchmarks, but in general, you write React components, you don't care too much about performance because it's never really a problem. The only exception is long lists when you have one little performance optimization you can add, but that's for another talk. So I wanted to kind of dive into how React came about and how it's possibly related to composability and jQuery. React actually started as a science project from the ads team at Facebook. There were kind of two people at Facebook that if they got hit by a bus, there would be no more Facebook ads. Or at least no one could create new Facebook ads, so you'd be stuck with all the old ones. Are people happy about that? Man, that's depressing. Ads engineers are people too. So they sent this guy Jordan off to go explore crazy ideas related to web front end, and he dropped something a couple months later that was React 0.1. So the legend goes it was written in OCaml. I don't know how true that is, but knowing Jordan, I believe it. And then the first thing they actually rolled it out in production with was the comment box on Newsfeed. So this is actually a very highly trafficked part of Facebook, and it proved it out. Now, the thing that makes this interesting is that they didn't rewrite all of Facebook Newsfeed to use React. They had to take over one small part of the page. Additionally, the way that they render text in here with these mentions is actually fairly complex. You can mention a page, you can mention a user. The way that these internationalize is a little bit interesting. So they didn't want to rebuild everything, just kind of the way that you write the comment and then the comment gets added to the list. So they wanted to add a new React component to represent this, and then within that React component, they wanted to reuse the old comment markup. So rather than rewrite everything, which can kill your company, they needed to compose this kind of correctly. They needed to reuse what they wanted to reuse and kind of not rebuild everything. So composability was paramount. So you want to basically be able to do two things. You want to be able to embed React inside of an existing app. You want to be able to embed an existing app inside of React. And what that lets you do is embed an existing app inside of React, inside of an existing app inside of React. So since this is a jQuery conference, and jQuery's got like seriously crazy plugins, like all the jQuery plugins, like jQuery UI is just so universal. I wanted to kind of show you how we would do that with jQuery, because it's pretty similar to how Facebook had to do this stuff. If you ever built a jQuery plugin before, you just attach basically a method onto the prototype. And React is pretty simple to drop in. You give it a DOM node, jQuery gives you a DOM node, and then you call this little create element thing, which instantiates your component, and React.render renders it into the DOM. So React was built from the ground up to kind of talk to this universal interface, which is the underlying browser DOM node. So give me a DOM node, and I will like blow away all the content inside of it and replace it with React. So if you're building Newsfeed, though, you're destroying all of the content inside of a DOM node. What happens if you want to embed an existing app inside of your React app? It gets a little more complicated because of the way that React works with this re-rendering on every update and the way jQuery works, which is this imperative UI. So the simplest way to do it is, or I should say the easiest way to do it, is to make a really simple React component. This wraps the jQuery UI date picker. You create an input field, and then there's a lifecycle hook in React called didMount, which says, hey, I just rendered. It's kind of like the constructor that fires after it's rendered into the DOM. You say, like, how should I set up this DOM node? And so you instantiate the jQuery plugin on the DOM node, and you're good to go. Now, the problem is when the React component changes, actually, if we go back, we pass this .props into the date picker component. This lets you pass parameters into the React component that then get passed in as options to the jQuery date picker. What happens, though, is that those props might change over time. And so since this only fires when it's initially rendered, it's not going to be updated. And then you kind of lose some of the benefits of React. So how do we deal with this re-rendering when the data changes? Well, one of the things that makes React actually really it's a really underappreciated part of React, but it's the way that it lays out lifecycle methods. And I actually think that this is one of the most important things that it brings to the table. You see a lot of different libraries kind of taking hints from React or re-implementing some of the ideas, and the blueprint for that is the lifecycle. So in this system, we have component didMount, which runs when the component is initialized and put on the page. And then we have a hook called component didUpdate, which is whenever the data may have changed, this method gets called. And so whenever the component gets re-rendered, we rerun the date picker plugin. So what that does is it basically, on every change that may have happened, we reinstantiate and we rebuild the date picker. And this actually works pretty well. Your date pickers will be live updating, and it'll play nicely with React. But for a lot of jQuery plugins, there might be performance problems, because jQuery plugins are designed imperatively, not reactively. So you have to build a little more of a bridge here. Remember how I mentioned that the virtual DOM gets diffed in React? We walk the virtual DOM, we figure out what changed. When you use a jQuery plugin, you actually don't know what virtual DOM changed because it talks to the real DOM. So instead, you have to fall back to diffing the data that you give jQuery in order to tell jQuery when to update itself or when not to update itself. Now, this logic can either live inside of the jQuery plugin or inside of your React component. Right here, I demonstrated it inside of your React component. We have a function that checks if these two data structures are the same. If they're different, we rerun the component. And that saves you a lot of performance. So what am I trying to get at here? We talk a lot about composability in this community, but it's not just about embedding some component like from some framework inside of other components from that exact same framework. Composability is about composing in both directions. You need to be able to take these heterogeneous environments and kind of put something completely alien in there and then nest something alien inside of that. This approach has worked well for our stuff on the web, and it's also working really well for React Native, where instead of composing different DOM libraries together, you're composing regular Objective-C code and JavaScript. Thanks for listening.